My name is Thinh.
My name is Christa.
My name is Janice.
We are Strop in Code, and we did a Steganography project. Our flatten function takes an input of a 400 by 400 image. We then create a zeros array the same size as that image. We then define a black pixel as any pixel value below 120 and give values at those locations a 1. This then creates an array of all zeros and ones. The expand works in the opposite direction, creating an array of zeros and 255s. We again take the size, create an array of ones, and then multiply that by 255. We then find all the black pixels from our flattened image and give those values a 0, which then fills in where the black pixels should be. For our method 1 embedding, we used odd even in the red layer. We first take only the red layer of the image we want to hide, our base image. We then index dark to be wherever our hidden image, flattened hidden image, is a 1. We then use the mod function to find wherever there is an even value. At those even values, we subtract 1. We then index dark and add 1 to our red layer wherever there's a dark image, therefore making it even. To recover our embedded image, we use the recovery1 function. We create an array of zeros, get the red layer from our new image, use the mod function to find any even value. Wherever this is even, that means we have a pixel. We make that a 1, and then this recreates and recovers our hidden image. Method 2 and 3 work in the same way as method 1, except we use the green layer and then the blue layer. The recovery works in the same way, except it again uses the green and the blue layers.
Method 4 is the red RMD4 and embeds by finding remainders of each pixel value divided by 4. We took the red layer from the original image, which is the first, used the flatten function to hide the image where ones was blacks and zeros was whites. We index these black pixels. We then used the mod function to find remainders of each pixel value divided by 4, and then index the remainders that were 2 and 3, the upper and half of those remainders. We reduced those pixel values by 2 of the original red at the index places, and then added the pixel values of 2 at the index dark places. Method 5 and 6 worked the same way, except 5 used the green layer, and 6 used the blue layer. Recovery was we took the red layer from the new image, which was the first layer, used the mod function once more, and divided by 4. The black pixels were remainders 2s and 3s. We set a pre-made blank 400 by 400 matrix, and then filled those blank matrices with the black pixels that were indexed black, and expanded this image into an RGB. 5 worked the same way, except using the green. Recovery 6 was the same, except using the blue layer 3. Method 7 used the mod function once more, except in this case, we divided each pixel value by 8. We then set the high half of the remainders, which were 4, 5, 6, and 7. And then at these index places, we subtracted by 4, and then added a pixel value of 4, and then set this as the new image. 8 worked the same way, except with the green second layer. And then 9 worked the same way, except it was with the third layer, which was blue. Recovery 7 was the same as recovery 4, except we're using mod 8, and then remainders 4, 5, 6, and 7. 8 was with the green layer, and 9 was with the blue layer. Method 10 was the same method as before, except we're using remainders of 16. Taking the top half, you go from 8 through 15. 11 green, 12 blue layer. Recovery 10 was again 16, and then remainders 8 through 15. The whole reason we used the remainders and the mod functions of 4, 8, and 16 was when we embedded, we didn't want to interfere with the previous images that we embed, and didn't want any black pixels which were white, or white pixels which should be black.
I'll be demonstrating our method 1 embedding, which is red, odd, even. So what we first do in our function is take an input of our base image and the image we want to hide. So first we use the mod function to make every value in our base image odd. So this will become a 239. This will become a 5. That's odd, odd, odd. This will become a 9, and this will become a 59. We then index our hidden image and find wherever there's a dark pixel, which is a 1. This is after we flatten the hidden image. We then index all locations where we have a 1 in the hidden image and add a 1 to the same location in our base image. So this becomes, again, a 240. This will become a 34, a 10, and a 24. Now when we want to recover these, we simply find all the even values, and that will tell us where there is a dark pixel.
So I'll be explaining our project GUI. It's called Project 2 Stegano, short for Steganography. And our first function is a callback with a tag called browse stock image. We have two other similar buttons. We use the command UI get file so the user can choose a picture, and out of it we get a file name and path name. We'll string it together to get the full file name using strcat. We'll create a global variable called method use. It's a 12-element array, all set to 0. 0 means the method hasn't been used, and 1 means been used. So the corresponding method, 1 to 12, will refer to the element 1 to 12. We'll create another global variable called stock picture, and we'll use imview to load the data of the file that user selected into that variable, and we'll show the picture in its corresponding axis graph using imshow. We'll set the edit string to be the full name stock, and that's for reference. The only difference between this and the browse hidden image is instead of showing the full file name, we show only the file name of the hidden picture. It's the same format, same thing with the browse embedded image. The user will choose the file that they want that has already been embedded, and it'll load it into a variable called load picture, and it'll show it in the corresponding axis using imshow. We have a save button. Basically load the global variable stock picture, and we use the command UI put so the user can put the file name that they want. The default name is embed, and it's a PNG file. We use the command imwrite to create that file. We have a clear button, which will reset everything. It'll clear all the graph axes and reset the tick marks, because we don't want the tick mark when we reset the graph because it doesn't look presentable. It'll also reset the method use back to 0, so when we redo the methods, it can work again. So all our embed or methods have the same format. We'll basically load the global variable method use, stock picture, and hidden picture, and if the corresponding element of the method is 0, so if it's the first method or embed 1 and the first element is 0, it'll run the method. It'll put the hidden picture in the stock picture and rewrite the stock picture. The axis will we'll show using the picture using imshow in the corresponding axis, and you get a message box saying it's been done. We'll then change the corresponding element value to 1, and so when we do choose that method again later, it will give you an error box. So that's the same for all our embed callbacks. It's just embed 5 will be used method 5 and so on. We have our recovery method. We'll basically load the variable load picture. That's basically what the user chose as their embedded image when they did that callback. We'll create a new global variable called recovery picture, and that'll be the data using the corresponding recovery method. And you also get a message box saying it's been done, and it'll show the picture in the corresponding axis. So that's the same for our recovery method from 1 to 12. It's just each one uses the corresponding recovery method. So recovery 10 uses recovery 10, etc. That's embed. Okay, so stock image axis handle will all set the ticks to be empty brackets, so it won't show the tick marks at the start of the creation. And our axis 7 is basically our background image, where we loaded a beach picture, and we used image SC to show that picture using a default color map. We use the command UI stack bottom, PG bottom, so we set the variable to be at the bottom layer, also cover everything. Okay, so this is our GUI, and our project was supposed to hide 10 hidden image inside. When we choose the file, it'll show the full file name and the picture right there. We get to choose our hidden image, which will show the file name and the picture right there. We can choose one of the embedding method, and it'll show the result right there. And you get a message box. That's one image. Oops. 2 image. 3 image. 4 image. 5 image. 6 image, 7 image, 8, 9, and so this is our 10th one. If we choose the method that we already chosen, it will give you an error box, say that you already done it. So that's our 10th image that we hide. You now save this as a file. Let's call it embed, and sure, overwrite it. You can reset it, so just clear off everything. You can choose our embedded image, which was called embed, and we click a recovery away, and we get that hidden picture. There's one. If you choose the wrong method, you'll get a message box saying that you have something wrong, and it's a messed up picture. So that's 2. That's not the right method, so that's 3, 4, 5, 6, 7, 8, 9, and finally 10. Thanks for watching.